or should we jump right in?
I think we can jump right in.
Okay.
So everybody,
Great.
this is Don from Math Whiteboard. He's the CEO of, what's it called? The actual company?
The name of the company is Fluidity Software, and one of our products or one of our tools is called Math Whiteboard. So let me actually, what I'll do is I'll share a screen with you. I'll share my screen with you, and I'll give you a quick introduction about me and about our company and about Math Whiteboard. Let's see here. Just get my PowerPoint presentation up.
I'm sorry?
Did you give him the rights to share?
It should be set up for him to share, but we can change it so everybody can share. Okay, one of us is frozen. It looks like, Don, you are frozen. Can you still hear us?
We're fine. I can just. Or I needed to plus. No, Linda, there's a seat over here. Well, I didn't want to block Danielle.
Hello, can you hear me
Okay.
now?
I actually think it's our internet connection that is unstable.
Okay.
I
No
don't know
problem.
where we can hardwire. Does anybody know in the room where we can hardwire?
No, I don't. I think there might be one over there, but I'm not positive.
Okay. Well, let's, if you freeze up again, we'll come up with plan B, but let's see if we can work through it. Where is our
Okay.
pod?
Tammy, you might want to turn off your video.
Oh, you know what? That will fix it. We're going to turn our video off and that should help it.
Okay. One of the things I've noticed is that when my with Zoom, and I don't know why this is, but I have a similar issue with Zoom. At some point during my presentation, sometimes this happens with Zoom. Zoom will just consume all of my CPU and memory on my machine, and then it becomes difficult to use. And what I've learned is that my webcam, for some reason, if I turn my webcam off, all of a sudden it gets better. So there may be a point at which if I notice that my machine's getting really slow, I may turn off my webcam as well. Can you all still hear me?
Yes, you are loud and clear.
Oh, great. Okay, good deal. So let me share my screen with you, and I will show you what I'll show you a couple PowerPoint slides here just to give a little background. As Tamara.
Okay, we just lost your audio, Dawn. Did you want to go ahead and try turning off your camera as well?
Oh, can you hear me
Yes.
now?
You just cut
Okay.
out there just for a moment.
Okay. Let me. I think the audio should be fine as long as my webcam stays active there. Usually, I've found that everything flows pretty quickly. But if you're noticing that my audio is cutting out a lot, let me know, and then I'll turn my webcam off, and we'll see if that fixes it as well.
Okay.
So as Tamara was just referencing, my name's Don. I happen to be the CEO and one of the founders of the company that makes Math Whiteboard, along with some other tools. The name of the company is Fluidity Software. I always talk about Math Whiteboard as the very first collaborative whiteboard designed specifically for mathematics. There are a lot of whiteboards out there. You're probably familiar with Jamboard and a couple other whiteboard applications. None of them really have mathematics tools built into them. Maybe kind of peripherally, they have some tools here and there, but ours is really a whiteboard designed specifically for mathematics. And a little background about our company and about me. Math Whiteboard has its origins in some PhD thesis work that was done at Brown University. That's where I did my PhD in computer science at Brown, and my team, we all did our graduate work in computer science at Brown. The research was done in a research lab that focuses on educational technology, user interface technology, computer graphics, the ways in which we interact with computers. And some of the research was focused on mathematics tools, specifically for teaching and learning of mathematics and exploring mathematics. And we're a very research-based organization. So we've been very fortunate to have received funding from the National Science Foundation and the NIH and the US Department of Ed after we took this research lab out of the research, after we took the research out of the research lab and have turned it into a tool for teaching and learning. And that has afforded us the opportunity to not only build the tool from an engineering perspective, but also study its use in the classroom. So that's it for the PowerPoint slides. Let's get into the fun stuff. I've got 2 browser windows on the screen here. You'll see 2 Math Whiteboards here, not because I'm trying to double up on the promotion of Math Whiteboard, but instead because I want to show you how Math Whiteboard can be a shared synchronous space for teachers and students. So let me start up. I'm just going to click the create or join a Math Whiteboard button here. That will bring me to the Math Whiteboard page, and then I click new Math Whiteboard. So let me give you a quick tour of Math Whiteboard. So before I get started, though, let me tell you a couple of caveats or a couple of things to start with. Math Whiteboard is a free site. It's just like a website, like any other website you go to. There are no account. I say that it's barrier free because there are no accounts, there are no subscriptions, there's no logins, there's no passwords. It's just a site you go and use. It also runs in a web browser, which means it pretty much runs everywhere, whether you're using a Windows device, like I happen to be using a Windows Surface here, or a Chromebook or an iPad or a MacBook or a Windows PC. You'll also see that I will be writing on the screen a lot with my stylus. And even though I'm writing on the screen a lot with my stylus, we also have a keyboard-based interface for folks who like to type instead of write on the screen. And that's actually what's interesting, and I'll say this a couple more times. If most of our users happen to be Chromebook users, and they happen to be using devices without a touch screen, so they're typing. So everything I'm doing with a stylus, you can also do just as effectively with a keyboard and a mouse. So let me show you what Math Whiteboard is all about. So think of Math Whiteboard as a smart piece of math paper. For example, I can write some math. Pretty simple math, 1 + 2, but you'll see it recognizes what I write, and I can get an answer. 1 + 2 is 3. I can change the math, and the answer will update dynamically. So 2 + 2 is 4. I can change this 2 over here to an A, and then I can assign a value to A. So when A is equal to 1, A + 2 is equal to 3. I can change the value assigned to A to a 2, and the answer A + 2 updates dynamically. Or I can change 2 over here to a B, and then I can assign a value to B. So when B is equal to 3 and A is equal to 2, A + B is equal to 5. I can write more math on the page, maybe A - B, or A times B, or A over B, and I can get answers for all these math expressions as well. Whoops, it didn't recognize my arrow there. I've just got to rewrite it. Now, underneath the hood, we also have a very powerful computer algebra system that allows me to do the simple numeric arithmetic you've seen so far and the algebraic arithmetic, but I can also do more advanced math on the page. So here's a definite integral. So this would be applicable maybe in the calculus class. Now, when I go back and I change the value assigned to A from a 2 to a 6, all of the answers on the page update dynamically. Or if I change B to a 7, again, all of the answers on the page update dynamically. I can even assign to A an expression like x + 1, and now x + 1 substitutes for A across the page. So as math educators, we all know that learning mathematics is about seeing connections between things. Here, we're looking at the relationship between A and B with respect to some operators, plus, minus, divide, and so forth. In algebra-oriented topics, we look to see connections between other types of mathematical representations, maybe math, algebraic expressions, and graphs, and tables, and diagrams, and so forth. Let's take a look at a math expression that we are all familiar with. Y = mx + b, the slope-intercept form of line equation. I've written it on the page. I recognize what I wrote. With a simple gesture, a stroke of my pen, I can create a graph. I'll do that again. Just a quick swoop of my pen. I've got a graph. I can pinch and zoom that with my fingers. You'll notice that there's something's plotted here, which means that we have assigned default values to m and b of 1 because the slope has the graph that's plotted has a slope of 1 and a y-intercept of 1. But I can change that. I can make m equal to a different value. I can say m = 2, and now the graph updates dynamically. Or I can make slope equal to 3, and again the graph will update dynamically. Or I can be more interactive by creating a slider for m, and now I can show very visually what m, or slope, really represents. What's slope? That is slope. When slope is positive, it looks like this. When slope is negative, it looks like that.
Hey, Don.
B is the y-intercept. Yes.
Can you show us one more time how to put that slider in?
Oh yeah, absolutely. So you create a slider in Math Whiteboard when you have an assignment, like a variable equals a number. In this case, you can see on the screen, I have b equals 1. That's an assignment. So when you have a variable on the left-hand side, an equal sign and a number, just draw a straight line down from the equal sign, just like that. You've got a slider. And now we can vary the value of b.
Okay, also,
Now, of course, I'm looking at, oh yes.
I think your math coaches are following along, trying to do what you're doing. So you're going a little fast. So what they're doing is they're repeating what you're doing to follow along.
Okay.
And then you're moving on to something else. And I think they're getting a little bit left behind.
Okay. Okay, I'll slow it down a little bit. Of course, keep in mind that Math Whiteboard does a lot, and I want to try to cover a lot of real estate here in the time that we have. So for some of the examples I'm going to be showing, it might be a little bit difficult to do exactly what I'm doing as I'm doing it, just because I jump through a couple of things really quickly. But just let me know, and I'll pause. I'll stop. I'll show you how to do things.
Okay.
So so where were we? Okay, we were varying the value of b. So now I'm changing the value of b, but I'm looking at the graph and I'm saying, holy cow, that's supposed to be the y-intercept. Why is the graph moving left and right and not up and down? It's supposed to be the y-intercept. Well, let's plot this point 0, b. And now when I graph b, now that the y-intercept is plotted there with the blue dot. Now when I change the value of b, now we can really see what the y-intercept is. It's that point where the red line passes through the y-axis. That's the y-intercept. So there's something I say often, and I think it's really important. Learning math is about seeing connections between things. Here we're looking at the relationship between an algebraic expression and a graph. Often in the math classroom, the math teacher, the math student, the mathematician uses a primary workspace for math. That's the paper and pencil workspace. But we have all these complementary workspaces like graphing calculators and computers, where we're looking at other mathematical representations, maybe graphs and tables and diagrams and animations. But we end up with these multiple workspaces that are all far from each other, not just physically, but cognitively. How do you see the relationship between what you wrote on paper with a pencil and what you have on the screen of a calculator that you entered with a keyboard? Those representations are far from each other. So what we try to do with Math Whiteboard is bring together into one workspace all of these mathematical representations, allow the user to move very fluidly between them, and then hide behind the scenes all the technical stuff. Let me show you another example that really demonstrates this in a powerful way. And just a quick warning, I'm going to run through this quickly. If you're trying to play along, it might be a little complicated, but you can practice. So I'm going to show you a related rates problem. We'll take a look at a couple of cars. So I'm going to draw, and by the way, I'm using the draw pen up here to draw the cars. The math pen over here is used to write math. So I'm using the draw pen. I'm going to draw a couple of cars. And I will draw a road. We'll say that, and I'm going to change to my math pen, and I'm going to write a math expression, a sub x equals ADT. So this is a math expression that's modeling the constant velocity of car A. That's in algebraic terms, that says the location of car A along the x-axis is defined by 80 units of distance per unit of time. Car B is a police car that has to accelerate to catch car A. I use a quadratic to describe constant acceleration. Now, in Math Whiteboard, we have this ability to connect hand-drawn sketches with handwritten mathematics. It's called math sketching. So under the More menu, I can turn on math sketching. And I get this little, oh, you know what I need to do first? I need to label the cars. So if I label this car A, and I label this car B, and we'll give length to the road. And now I've turned on math sketching, which brings up this little slider. And on the right-hand side of the slider, there's a play button. When I press the play button, I heard some oh wows. Pretty cool for us, and we're adults. Imagine what happens when you show this to kids in the classroom. All of a sudden, their hand-drawn sketches come to life as described by the mathematical notation on the page. And of course, from a high level pedagogical perspective, what's happening here is we're making a connection between this, this very abstract algebraic notation on the left-hand side and this very concrete example on the right-hand side. And sometimes that's when learning happens in the math classroom, when we learn that that abstract stuff we're learning in the classroom actually has an application. And in fact, with algebra, we can apply it in so many different ways in pretty much everything we do. Cars driving along the street is just one of many, many applications. Of course, this is also from a practical perspective, this is a related rates problem, and related rates problems show up on standardized exams all the time. They usually come with a couple of questions, like at what point in time does something happen, or at what point in distance does something happen? Here, the question is, when does car B overtake car A? We can see from the simulation, it happens right about there. Well, that's a math observation, not a math answer. We want to get the math answer. How do we do that? A couple different ways to do that. You saw earlier that we have this powerful computer algebra system underneath the hood. I could set the equations equal to each other and solve, and Math Whiteboard would allow me to do that if I knew what the notation was. But another way to, and by the way, I do know what the notation is. I just so another way to solve this is to explore, and this is the way I like to do it, kind of using the scientific method here to come up with a hypothesis, test the hypothesis, and then prove it. And the way you might do that with this example is you might graph these two functions. So I'm gonna graph these two functions here. Oh, by the way, I did one graphing gesture through both math expressions, and I got a graph. And now we can see the graph is plotted. We can see the parabola, the quadratic, and the linear. And we'll notice that there are points of intersection, one at the origin, one out here in the quadrant. The one in the quadrant, that's what we're interested in, because that's when the quadratic overtakes the linear, or when we hypothesize that car B will overtake car A. We can see that happens in the graph at about 8 units of time and about 650 units of distance. So that's our hypothesis. When time equals 8, the car should be at about the same spot, and that spot will be about 650 units of distance along the road. So let's test the hypothesis by running the simulation for 8 seconds. I'm just going to drag the T slider time over to 8 to see if the cars are at about the same spot. Okay, looks like they are. We haven't proven anything yet. We know we're on the right track, though, because the cars look like they're at about the same spot, and the graph looks like it's at about that spot as well. So, but we're eyeballing things. Let's prove it. The way we prove things in algebra sometimes is through substitution. So I will substitute in the value of my hypothesis when time equals 8 to see if the location of car A along the x-axis is about 650. Let's see. 640, that's pretty close. If B sub x is 640, then we have proven the hypothesis. Okay, cool. So I love this example because it demonstrates the power of having multiple representations in one workspace, and everything is connected. You've got the algebraic representation, you have a simulation, you have a solution, you have a graph. You could look at a table of values also. And everything is connected. So when the student goes back and says, hey, make the car go faster. Well, you can just change the 80 miles an hour over here to 90 miles an hour. And look, all of a sudden, the graph changes. The point of intersection moves, and the solutions change as well.
There was a question, Don. How did you get that magic table?
Oh. There's a table button right there. Right there, just click the table button, the table comes up and goes down. It's a toggle. So you click the button, it'll show you the table. Good question, though. There's still a lot more to show, but let me pause for a moment and see if there are any questions.
No, I think we're good. Keep going.
Okay, great. So I'm going to click, I'm just going to create a new whiteboard here just to clean the slate. So there's another bit of functionality here that I think is very unique to Math Whiteboard. I don't think you'll see this anywhere else. And I'd love to get your feedback on it because I think it's pretty cool and potentially very useful from a pedagogical perspective. We have this ability within Math Whiteboard to test for equivalences on a page and to display equivalences visually. Let me show you what I mean by that. So under the More menu, I can turn on Highlight Equivalence. What this will do is it will highlight anything on the page that's equivalent to anything else on the page. So for example, 3 and 2 are not equivalent, so they're highlighted different colors. And 4 is not equivalent to 3 or 2, so it is yet again a different color. But 6 over 3 is equivalent to 2. So now it's color coded the same as 2. And 4 over 2 is equivalent to 2. So now it's highlighted the same color as 2. So you can imagine using this at the lower grade levels where we're looking at equivalent fractions and decimals and percentages and so forth. But this is also applicable at the higher grade levels where we're looking at equivalent algebraic expressions. So for example, a plus b and b plus a are equivalent. So they're color coded the same. A minus b and b minus a are not equivalent. So they're color coded differently. And then a times b and b times a are equivalent. So they're color coded the same. And then a over b and b over a are not equivalent. So they're color coded differently. Pretty good for simple algebraic identities like these. But we can also apply this at the higher grade levels where we might be looking at trigonometric identities. So for example, tangent of theta is not equal to sine of theta. But so they're color coded differently. But sine of theta over cosine of theta is equivalent to tangent of theta. So now it's color coded the same. Now, pretty cool for looking at identities and equivalent expressions. But perhaps the most powerful way in which to use this highlighting of equivalent expressions is in step-by-step problems. Let me show you an example. So let's take a look at this. 2x plus 3y equals 4. Okay, so if we were to solve this for x here, what would we do? The first step we might take is we might move the 3y over to the other side. So let's do that. The first step here would then be 2x equals 4. And then we're moving 3y over, right? So we'll say plus 3y, right? Wait a second. I must have made a mistake, right? Because these two expressions are color coded differently. We know that every step in a step-by-step solution should be algebraically equivalent to any other step in a step-by-step solution, but these two are not color coded the same. Huh? I must have made a mistake. Now I heard someone say that they pointed out the mistake I made. That the plus, I should have changed the sign for the plus to a minus. So let's do that. Let's change this plus to a minus. Cool. Okay. Now I fixed my mistake and now I have the confidence to move on to the next step. So what we've done here, of course, is we've given immediate feedback in the middle of a step-by-step solution that we've either done the step correctly or we've made a mistake, and we can fix it immediately as we're making the mistake. So now we can continue on and we can solve. So x is equal to 4 minus 3y over 2. All right, so now that's color coded the same as the other two steps. So now I know that I've gotten the solution correct. So one of the reasons I like this color coding stuff here is because as we move on in our math education, these step-by-step problems become lengthier and lengthier. They could be 5 or 10 or even more steps long. And students, when they're solving these, can be investing a lot of time. These can take 5 or 10, even more minutes in order to solve. And then especially for the students who are struggling to get to that last step, only to realize you got it wrong. You got the answer wrong. And you're looking back daunted at all the math that's on the page saying to yourself, oh man, what did I do? What did I do wrong? Where did I make my mistake? And you're looking back and stressed out and you're saying, oh man, should I start over again, erase the whole thing and start over again? Or, hope for some partial credit and I'll just move on to the next question. What do y'all think about this color coding stuff?
Like it. Yes, love it. Love it.
You like it? All right, cool, awesome. I'm sorry, is there a question?
No, they were just saying where they could see it being used in Algebra 1, Algebra 2, and then Andrew said all of them.
Yes, totally. The fun thing about, the fun.
Hey, Linda has, before you move on, Linda has a
Yes,
question
it's
for you.
Yes.
Can you graph earlier? You had it in slope-intercept form. Can you graph from other forms? Or does it have to be
You can.
form?
You can. So for example, this expression is not in slope-intercept form. So I could just, I can graph that expression if I want to, just like that.
Oh, wow.
Or I can graph this one here as well. Or I can graph this one here. Or I can graph them all in the same graph area by just one swooping gesture through all. And you can see they're all lined up over each other. Difficult to see.
It's cool that when
they're
you
all
made
lined
3
up.
separate graphs, it proves that it's the same graph.
Yeah. Good stuff.
Yes, so far.
Okay. Oh, one thing I'd like to just comment on here. I know I mentioned earlier that that we have a keyboard interface. So if you're looking at this and saying, "Oh man, some of my students like to write on their screen," or maybe the students don't have a touch screen, they like to type instead of write. But in the middle here is math typing mode. So when I turn on math typing mode, I can type math on the page. So if you were a real stickler, you might expect an intermediate step here between these two, where we subtract 3y from each side. So the step that we missed might have been 2x plus 3y minus 3y equals 4 minus 3y. So you'll notice that's the same color. So whether you're typing on the screen or you're writing math on the screen, the color coding works in either way, and it matches. The color coding between the handwritten math expressions and typed math expressions match as well. So let me continue on. I'm going to just create a new whiteboard here just for the sake of having a clean slate. I mentioned this earlier on that math whiteboard can be, yes.
Okay.
So I wrote an equation, but I had a break in between. Is there a way to pull it together? Because I did 3x plus 2y, and then I put equals 6, but the equals 6 was separate from it. Can you push it together?
Oh, so you did something like 3y equals 2 plus 6x, something like that.
It's separate. Can you pull it?
So right at the top, if you're right at the top, there's a little green, you see the little green box there? That's actually a handle. You can just grab the handle and drag your math expression around the page. And we can drag it a little closer there, and all of a sudden it becomes part of that original expression. And then of course there's another green handle up here, and I can grab that green handle and I can move this expression around as well. Good question. You guys are playing along, I can tell. So let me I'm going to create a new math whiteboard here just for the sake of having a clean slate. So I mentioned early on that this is the first collaborative whiteboard designed specifically for math. And what I meant by that is that by collaborative whiteboard is that this can be a shared synchronous space as well. You'll notice at the top of the browser window, there's a URL. Every math whiteboard has a unique URL. You can see that up here. When I click copy link within the math whiteboard itself, this little button, copy link, that will copy the URL to my clipboard. And then I can take that URL and I can paste it into like a Google Doc or a Microsoft Teams channel, or my course web page. I can just email it to someone. I'm just going to paste it over here in the browser window on the left-hand side. And these two browser windows now, for the sake of this demonstration, represent two different users on two different computers. So you might have a student on the left and a teacher on the right. So maybe the teacher starts the conversation by writing some math on the page. So we write y equals x. And you can see that it shows up on the student's screen on the left. But this is a shared math whiteboard. So both users can edit at any time, simultaneously or synchronously. So the teacher wrote that originally on the right. I'm going to edit it on the left. So maybe we make that mx plus b over here. And the teacher can see that the math expression has been updated. And of course, all of those mathematics functionalities that we've seen so far, like putting graphs on the page and putting sliders, they are all available to any of the users at any time here as well. So one of the things that we've seen teachers doing, which we think is really cool, is that they're using pages within Math Whiteboard. So Math Whiteboard, you just saw me pop this thing out from the left-hand side. Every Math Whiteboard can have multiple pages. You can click the plus button up here and get a blank page, or you can click on any page and just hit Control-C and Control-V. I'm going to do that a few times. So what we've seen teachers doing is, for their classes, is they'll assign groups of students to each of the pages. So for example, on page 1, we'll have group 1. On page 2, we'll have group 2. on page 3, we'll have group 3, and on page 4, we'll have group 4. So let's say, for example, the students on the on the left-hand side here are on page 3. And maybe this is Mary and Billy working together. So Mary, they're going to change their pen color to green. So Mary, she's pretty diligent. She's going to write some math on page 3. And the teacher over here on the right-hand side can see that page 3 has been updated in real time. So even though the teacher's on page 1, teacher can see on page 3 there's been an update. But Billy, he's kind of goofing off. So he's drawing smiley faces. So again, the teacher can see that there's been an update and a smiley face on page 3. So the teacher can go on page 3, turn on the red markup pen and say, hey, what's going on over here? What are you doing? That's not math. So kind of an interesting way for teachers to have students working in small groups while watching what they're doing in real time as it's happening.
Now, I remember when you met with Amber and I, you talked about how long this page or the series of pages will last.
Mhm.
At the
Yeah,
time, you said it was indefinite, so you could have the kids working on one day and then meet with them in small group on a different day?
That's correct. Yes. We don't delete any of these documents yet. There may come a time in the future where we make pages expire after some period of time, maybe 30 days, maybe 6 months, maybe a year. But we haven't yet done that because we expect at some point maybe our database just gets so filled with these whiteboards that we have to clean them up.
Not
I'm
yet.
sorry, was there a question?
Kim was just saying that we would just have to save the link because there's no place for it being saved, and we can just come back to that link repeatedly.
That's correct. Yes.
Don't lose your link.
Oh yeah. And I'll talk about this at the end, but so in Math Whiteboard, one of the challenges with creating a system that has no accounts and no passwords, no logins, is that it's difficult for us to make an association between these links and someone like yourself, like a teacher. And we built this system because we wanted to build something that's really powerful, barrier-free, and just any teacher could use. And the initial concept for Math Whiteboard was that it was kind of like your whiteboard or your chalkboard in your classroom, where you show up and it's a blank slate and you can start using it. And at the end of the period, you clear it, you clean it, and then you start using it again with the second period. But a question similar to the question that was just asked has been asked a lot. And the question is, how do I save these things? If I have, multiple periods during the day and I want to create an activity and have the students do the activity, how do I create or make copies of these documents so I can use them over and over again? One way to do that is that you can copy any page in the Math Whiteboard. So for example, on the right-hand side, as I did a moment ago, I can just hit Control C on this slide over here on the right, and you'll notice on the left, I just created a brand new Math Whiteboard. It's a totally different whiteboard. It's got a different URL and everything. But I can come to any whiteboard and just hit Control V over here, and I've got a copy of that Math Whiteboard, and it's a copy. So when I write on the whiteboard over here on the left-hand side, it does not update the whiteboard on the right-hand side. That's one way to make a copy. Another way to make a copy, and this is what has become actually pretty popular. We have another system. It's called Fluid Math, and as you saw on my initial slide deck, our company's been around for a while. And this Math Whiteboard is actually a component within our other product called Fluid Math. Fluid Math does some other stuff. But because so many folks have been asking that same question, how do I make copies? How do I reuse them? Because maybe I have an algebra class today, and then tomorrow I have the same class, but a different period, or I have another section that's a week or two behind the first section, and I want to reuse that activity, but I want to hold on to it for a couple of weeks and reuse it, or maybe next year I want to use it again too. Fluid Math, and I can show you if you're interested, I can show you this a little later. Fluid Math has accounts. It's a subscription-based system. It has accounts. You can save these things, and then you can. We just add, because so many folks have been asking this question, we added recently some functionality to Fluid Math where there's a save button, at the top of the page and a share button that allows you to save these things in Fluid Math, but then share them as math whiteboards. So what we've seen is that a lot of math teachers are just getting the Fluid Math accounts for themselves, and then they are building their activities to reuse them and then sharing them as math whiteboards. So in that scenario, the teacher has a Fluid Math account, and then the students just are using math whiteboard. So there's lots of different scenarios, and the Fluid Math system is actually pretty cheap for teachers. So anyway, let me continue on. I've just shown you this capability for Math Whiteboard to be a shared collaborative space. A couple other bits of interesting functionality here. I'm going to just dismiss this page on the left. One of the favorite features for math teachers of Math Whiteboard is this bit of functionality. I have a folder here with some PDF files in it. Math teachers are well known to have a lot of PDF files that look like worksheets. I'm going to open one here, slope from a graph. Just open this up here. It's just a PDF file. It's an Acrobat Reader. I'm just looking at this. Wait, I'm sorry, what's that?
When you said worksheets, Angie just about choked.
Uh-oh. Some folks don't like worksheets. I'm sorry. And some folks, but in general, they're really good for practice. Whether you like them or hate them, they're a part of life in the math classroom. You can take any PDF file and you can drag and drop any PDF file into Math Whiteboard, and it becomes the background for your Math Whiteboard, upon which you can do all your cool Math Whiteboard stuff. So I can write math on this. I can put graphs on the page. I can put more math and get solutions on the page, or I could just use this Math Whiteboard as a tool to mark up the PDF, like an annotation tool for PDF files. So I can turn on my draw pen over here. I can mark up the graph. Okay, up 1/2, up 1/2, right? Or I can change the pen color and I can mark this graph up over here, over 2, down 2, over 2, down 2, right? So what was a static PDF file that we printed out on paper and gave to our kids now becomes a live, interactive, dynamic mathematics web page that can be shared synchronously. So in the same way that we shared that Math Whiteboard page, the blank page before, you can share this as well with this content built into the background. And by the way, this PDF file had multiple pages. So this was a 4-page PDF file here. So every page comes in as a different page in Math Whiteboard. A couple other things I want to share with you here.
Before you answer, does it have to be PDF, or can you use Word or images? Oh, Word didn't work.
You can,
all right, so is PDF the only format?
you can do image files or PDF files. Microsoft Word documents can be saved as PDF, so you can always go to the file menu in Microsoft Word and save as PDF, or print to PDF. So it's really just PDF and image files like PNGs or BMPs or GIFs or JPEGs.
Before you go on to your next thing, I actually have a question that might be relevant to other people in the room. One of the things that sometimes happens is that teachers assign things to students or groups of students. Is there a way of, like in Google, you can put a copy in the end and everybody that clicks that creates a copy automatically? Is there a way of doing something like that? Or is it something you can just do in Fluid Math?
That would be something you'd probably end up doing with Fluid Math. We added 2 bits of functionality for Math Whiteboard in Fluid Math. So if your students happen to have Fluid Math accounts, everything that you just asked for is possible within Fluid Math. But if your students do not have the Fluid Math accounts and you want to do what you just suggested, in Fluid Math, there are 2 ways to share a Math Whiteboard. One is to just make a copy of the Fluid Math document as a Math Whiteboard, and you get 1 copy of it. You can click that button as many times as you want and get new Math Whiteboards, or you can click another button that will give you what we call a start URL. And the start URL, every time you click the start URL, it generates a new Math Whiteboard that is a copy of that original document.
Okay, thank you.
Again, I can show you that as well if you'd like to see. So let me continue on here. The one thing I mentioned this earlier, and just I like to show you some of the other bits of functionality that are also pretty popular. One of them I mentioned earlier is this keyboard interface. So far, I've been using the draw pen right up here to draw things like a smiley face. And I'm using the math writing pen up here to write math on the page, like 2 + 2. You would not use the math writing pen to draw a smiley face because that, Math Whiteboard tries to recognize it, but it doesn't do a very good job. So that's not a math symbol, even though maybe a smiley face should be a math symbol. It's not yet. Right here in the middle, though, there's math typing mode. So when I click on math typing mode, now you saw me do this earlier, I can type math on the page. So I can use my physical keyboard. I'm just going to type y = ax squared plus bx plus c, right? I use my laptop keyboard to just type that, but not everyone knows how to type math with their physical keyboard. Like, how do you type x squared with a physical keyboard? You have to know the key sequence. Shift-6 gives you the superscript for that. And then you have to hit the space bar to get down to the regular level. Not everyone knows how to do that. So down below, we have this, what we call a virtual keyboard, or it's like a calculator keyboard. I can click on math expressions, the math symbols here, like y = x squared. And now I've got that typed math expression on the page. Now, for new users, they always think that you can do that cool swooping gesture for typed math expressions. That's not actually the case. Instead, what you'll do is just go to the insert menu, select graph. It puts a blank graph on the page. And now all of a sudden I can drag and drop those math expressions right into the graph area, and they are graphed. And by the way, you can click on, in any math expression, you can click on the free variables like A, B, and C, and you get sliders. So I'm going to click on A, I get a slider for A. Click on B, I get a slider for B. Click on C, I get a slider for C. And now I've got those sliders, and you guys know what sliders do. Sometimes it's really nice to have typed math on a page because it looks better. It's just more well formatted than my, my big ugly handwriting here that, maybe doesn't look so good and takes up a lot of space. So underneath my handwriting, that's actually a button. When I click that button, my handwriting will go away and I'm left with just the typeset math. And by the way, I can graph that if I want to. I can graph that over here. If I want, I can put another graph on the page. There's a couple different ways to put a graph on the page. Drawing a big plus is a gesture for creating a 2D coordinate plane. I can graph that over here too. And in the middle, I've got this, both expressions have a B in it. And on the right-hand side, I can, I can see that there's one B slider, but there's a couple of graphs and math expressions with a B in it. But when I change that one B slider over here, everything on the page associated with B will update dynamically. Pretty cool. So, but let me show you one more thing. Since we were talking about this being a more well-formatted page, we may want to put some instructions on the page. If this is something we might want to hand out to the kids, we can put some instructions. There's a text box button up here. When I click the text box, I can now type some text on the page, like some instructions, like play with the sliders, right? And you can make those instructions as involved as you want. But these text boxes are actually really cool. I'm just clicking that tab there because one of the things I want to show you is that with these text boxes, I can embed like things like YouTube videos into these text boxes. Let me show you. So I have this tab here, this browser tab. I have, this is a SolCon video talking about quadratic equations. And as you know, with all YouTube videos, there's always a share button. I can click the share button and I can get like, the link to the video directly, or I can get like the embed code. So when I click on the embed code, I can copy that embed code. And now I can go back to my Math Whiteboard, click edit on that text box, insert media, and now I can paste that embed code here. And now I've got a SolCon video or any YouTube video embedded right there in my Math Whiteboard. So when I click on the Math Whiteboard, I'm sorry, when I click on the YouTube video, it plays right there. It's embedded. It's playing there right in the Math Whiteboard. And that's keeping in the spirit of Math Whiteboard where we want to stay in the same workspace the whole time. As soon as we have different representations or things outside of that primary workspace, all of a sudden we lose the connections or the relationships between all the things we're looking at. Sometimes when you click on the YouTube video link, it opens up in a different browser tab, or maybe a browser window, or maybe, you're having other representations on other devices. And, the spirit of Math Whiteboard is stay in the same workspace, and you can see all the connections between things.
Dawn, does it have to be YouTube? Like, could we do an embed video from WeVideo?
Anything that has an embed code you can do. So
Okay.
if you can get the embed code from anything, I mean, you'll notice with YouTube, it's really just, well, you guys are getting a little nerdy here, a little coding here, but it's just what's called an iframe. So if you can get the embed code, which usually is just an iframe, you can stick it right there. Any other questions at the moment?
Well, we have restricted mode for YouTube, so as long as it's watchable, and I'm going to talk about that today because ClipGrad just got disabled in our district. Well, yeah, sorry, but that's yes, YouTube can be watched by kids as long as we've approved it. Yes. Sorry, Don, go ahead.
No problem, no problem. So a couple more, one other thing I want to show you about Math Whiteboard. And this is another math teacher favorite here. If you all create assignments or assessments in your math classes, this might be useful for you. You can take anything you've written or typed in Math Whiteboard. You can get the typeset for that and then paste it into like Microsoft Word. So for example, if I have here's an example of a math expression that if you're a real jockey at the if you're really good with the equation editor in Microsoft Word, entering something like this in Microsoft Word might be easy for you. But if you were if you find it challenging to use those equation editors, this might be a benefit for you. So anything you type or write in Math Whiteboard, if you right click on it, you get a little menu that pops up, and this will give you the various typesetting languages that you can convert that into. So I'm gonna click copy presentation MathML because that works really well with Microsoft Word. So when I click that, that'll copy the MathML for this math expression into my clipboard. And now when I bring up Microsoft Word and I just hit Control V to paste it, now I've got that math expression right in Microsoft Word. And by the way, I can cursor through this and change it if I want to, or I can make a copy. This is editable in Microsoft Word, so I can hit Control C, Control V, and maybe I want to hit Control V here, and maybe I want to change the denominator on the second one here to x+3 instead of x+2. So kind of cool, I think, bit of functionality. It might save you a little time as well if you create your own quizzes. So let's see. We have a little bit more time left here, about 10 minutes. If you'd like, I can show you fluid math, or if you have any questions you'd like me to answer, I'm happy to answer any questions.
Well,
Linda has a question.
okay. Just back, like when you were using the draw features, I'm just thinking about courses outside of Algebra 1 or above. So like you were showing like equivalences with numbers, with fractions. Can you draw representations and then show equivalences between representations?
Did you get that?
That's a great question. I love it because I love it because it's a really cool, innovative idea that we don't yet do. But I think it's really possibly a cool thing to do. Can you give me an example of some representations that you might want to see equivalences between?
Like fraction equivalences, like not from a numerical standpoint, but from a pictorial representation. Where you had something divided into thirds, and then you had an equivalent divided into sixths, so that we can see that 2/6 was the same size as 1/3.
Oh, interesting. So kind of like manipulatives.
Right. But
That
more
might
like
be
drawing those
equivalences.
representations, because
I love it.
anyway, I just wondered if we could do
We just gave you
No,
homework.
that is a great. I love it. I love it. That's a great idea. stay tuned. Maybe we'll go do that. Maybe we'll run off and go do that.
Area models of binomials or something like that, like where you would be
Yep.
multiplying x plus 3 times x plus 2, and you did an area model. Can you do any kind of drawing like that, area models, and see equivalences with that?
Mhm. Yeah, I love it. That's a great idea.
Linda, you've got a new job.
Linda, what are you? Yeah, what are you doing next year, Linda? You ready? You sure
I'm getting close.
you ready to move to? Are you ready to move to Boston?
No, I don't want to move. No. Right. Okay. All right. That was the only question I had.
Okay,
No,
and you
that's
have
a great-
homework,
what
and
a
you have
great-
homework, Dawn.
Yeah. Let's see. You know, if there are any other questions, or if you wanted to see a little bit of fluid math, I can show you that. Fluid math has some additionally cool bits of functionality that I haven't shown you here.
Okay,
if
go
you'd like
ahead.
to
I
see
think
that as
that's
well.
It doesn't do the number line, you know, like the elementary use.
okay. There is a question about the number line for elementary use.
Or even just integer operations, anything like that. Where you can use it, number line.
Let's graph this expression on a number. Oh, by the way, I created the number line by just drawing a straight line across the page. That's a gesture for creating a number line. Another way to put a number line on the page is go to the insert menu, select number line, and now we've got a number line. We can take any math expression and graph it, and then of course H, we can make a slider out of H here, and we'll just create a slider for that. And now all of a sudden, you know, we're manipulating that. Did that answer your question?
Can the number line be incremented differently than the integer?
Did you hear that?
Yep. So in the number line, you'll notice when your stylus is or you know, or your mouse. If I put my mouse or my stylus into the number line, if I drag up and I drag down, that will squish and stretch the number line. I can also, this little drop down menu on the number line will give me discrete or continuous values. So if I'm not happy with the discrete values, I can stretch, and now I can get
Oh, there you go.
my continuous values there.
That'll work.
Okay.
Thank you.
Oh, you're welcome. So let me jump in. I'll show you a little bit of fluid math. I'm going to dismiss the math whiteboard pages, and now I'm going to jump over to the fluid math pages. And one of the really cool bits of functionality in fluid math is that you can create assignments or assessments or exit slips, you know, activities that your students might work through. And we have a pretty cool bit of functionality that, again, I don't think you'll see anywhere else. It's called a math answer box. Let me show you what I mean. So this is fluid math. Oh, by the way, yeah, this is fluid math. Looks a lot like math whiteboard, doesn't it? You know, the core bits of functionality are here. So I can write math on the page, and I can get graphs on the page, and it looks just the same as math whiteboard, right? But you'll notice that there are a few buttons up here that are different. There's a docs button, a save button, and a share button. These buttons allow me to save things. So the docs button in the middle there, when I click the docs button, I get like a doc browser that you typically see in other applications, where you can have folders and you can have documents and so forth. I happen to have like 2,300 documents here, but so there's a lot of you can do all sorts of great stuff by saving and organizing your documents. I'm going to create a pretty simple document here, like an exit slip. Let's do a pretty simple one. Y equals 2x plus 3. And I'm going to graph this, and I'm going to pinch and zoom the graph so we can see the y-intercept. And I'm going to, underneath there, I'm going to click that button right there. So I get rid of, so I have a more well-formatted page here. And then I'm going to put a text box on the page at the top here. I'm going to say, whoops, I clicked it twice. I'm going to say, what is the slope in the equation below? Okay. And let's put another question on the page here to ask about the graph. We'll say, what is the y intercept graph? Okay, so I created what looks like, exit slip, maybe a simple assignment or assessment. Pretty cool so far, but this is where it gets really cool. Under the insert menu, we have this thing called a math answer box. When I select math answer box, it puts a little box on the page here into which I can put the answer. So what is the slope? The slope is 2. And then I'm going to put another math answer box on the page here. And we'll put this down here. And we'll say, what's the y-intercept? The y-intercept is 0, 3, right? I've created what looks like, a simple quiz or exit slip. I'm going to save this. I'm going to click save. And I'm going to pick on you, Linda, but since you asked such a great question before, or such a great suggestion, I'm going to call this Linda 1. That'll be the name of my assignment. Oh, by the way, you can save things as either individual documents. That means people are going to work on it individually, or as collaborative documents where this will be a document that could be shared synchronously, just like a math whiteboard. So I'm going to click save here. Now,
Put multiple answers. It's like that second box. What if a student just typed 3? Could I put that as an answer choice also?
That's a great question. At the moment, the answer boxes will test for equivalent answers that are algebraically equivalent or numerically equivalent, or in this case, equivalent to the coordinate pair. Actually, no, not equivalent. It would have to be an exact match to the coordinate pair, I believe. But in the future, we'll probably allow for that. So at the moment, we were recommending to everyone, when you put your question on the page, be explicit about the type of answer or the form in which you would like the answer. Like, you want the coordinate pair form, or you want just a b value. We do allow for the student to write, b equals 3 or just 3. So if you wanted it, or m equals 2 or just 2. So that would work. But for those other forms that are not necessarily equivalences, they're just kind of correct answers in different forms, then what you'd want is you want to be more explicit in your question.
And Amber, you also had a question?
Yes.
Oh, okay, 2 for 1.
Okay. So earlier I told you can share any fluid math document as a math whiteboard. So I just built this in Fluid Math. And when I click on the docs button here, you'll see that there's a doc here. It's called Linda 1, right? That's the doc we just created and saved. So what I want to do here is I want to show you first how you can share this as a math whiteboard. So under the share button, I click share and I say open copy in math whiteboard. Now that will open the copy in math whiteboard as a math whiteboard. So now we can have, and I'll just open up another math whiteboard page here. So let me get that. I want to get this page here. So you'll notice that there are no answers in the answer boxes, right? That's because this is a math whiteboard that we're sharing with students. And so what I'm going to do is I'm going to copy this link here, and then I'm going to paste that link over here in the left-hand browser. So this will be like 2 students working together on a math whiteboard that you just handed out. So maybe the student on the right turns on the green markup pen, and the student on the right says, okay, I'm going to start working on the first question. What's the slope? The slope is 2. So m is equal to, and then the student on the left says, oh, we got to change, we got to show our work. So let's mark up the graph. So the student on the left, who's got a blue markup pen, marks up the graph, right? So the student on the left says, okay, I think m is equal to 2 over 1. So the student on the left writes in a 2 over 1. And you'll see the system comes back with a check mark. So the system tested for the correctness of the answer there. You'll see at the top, it says equivalent because the student entered an answer that's equivalent to what was expected. If you recall, when we created the assignment initially, we wrote a 2 in there, not 2 over 1. And 2 over 1 is just, it's a good answer. It's just equivalent to the original expected answer. And then down below, the student on the left-hand side says, okay, so what's the y-intercept? The y-intercept is b is equal to, and then the student on the right says, let's mark up the graph. It's equal to 3. So the student on the left writes in, okay, so the y-intercept must be 3, 0, right? And then the student on the left says, you got it wrong, dude. It's supposed to be, you're close, but no cigar. It's supposed to be X comma Y. And then the student on the right says, oh, thank you so much for helping me out. Let's change that to 0, 3. And now the system comes back with a check mark indicating the answer is correct. So kind of a cool way for you to build these activities in fluid math. And they're not just activities where the student kind of works through them. They can also be activities with these math answer boxes that will test for the correctness of the answers.
So Dawn, since you assign this as an assignment, even though it's collaborative, it's now in Math Whiteboard. Would you have to keep track of those links separately because they're not in fluid math anymore?
That's correct, yes.
Okay.
So now these are Math Whiteboard documents. This is a great question, because now in this scenario that I just showed you, the teacher has the fluid math account and is building activities and sharing them with students. If the students also have fluid math accounts, they can, and let me show you how that would work. So we're back at this document by the teacher. So I'm going to dismiss the Math Whiteboard over there on the left. This is the teacher. I'm going to just dismiss this little pop-up here. So instead of making a copy of this and sharing this as a Math Whiteboard, we can just, if our students have accounts, we can just distribute this to all the students in the classroom. So under the More menu, I can click Add to Classroom. So we're still on this Linda document over here, on Linda 1 document on the right-hand side here. And I'm just going to click Add to Classroom. And now I get this little dialog that pops up, and I can assign this to students in any of my classes. I can select, I have Algebra 1, Period 1. I have a couple other classes here. I'm going to just hand it out to kids in one of my classes, Algebra 1 class, Algebra 1, Period 1. Now I can hand this out as an individual assignment where the students are working on it on their own. It's an individual assignment, or as a collaborative assignment. What a collaborative assignment means is that I'm going to hand this out to groups of students to work collaboratively. So down below, as soon as I clicked on collaborative, this little groups button showed up. When I click the groups button, now I get all the students in my class. I only have 4 students in my class. You might have 20 or 30 or 40 in your classes. I can assign students to groups. So I can drag and drop these students into different groups here. Maybe Mary and Billy will work together, and Tara and Dawn will work together. And I could save these groupings. So, if I go through this manual process of creating groupings and I want to reuse those through the school year, I can save the groupings. You can see down below, I have a couple of groupings already saved. I'll click this Unassign All. That just unassigns the students. So if I were to click on a grouping that I had saved, for example, Dawn's grouping, the students, get immediately assigned to the groups that I specified in Dawn's grouping. Other ways to do groupings, down here below, you can see split unassigned into groups of. So this will randomly assign students to groups of 2 or 3 or 4, or however many you want. And then you can name the groupings, like maybe on Tuesday, you have groups of 2. And on Thursday, you have groups of 3. So you can have multiple groupings and then use them when you wish. But instead of doing this as a collaborative assignment, let's just do this as an individual assignment to start with.
Hey, before you do that, what's team game?
Oh, someone is very observant. This is it's a good question. It's a project that we have going at the moment. It's not released yet. But the idea here is that the collaborative assignments are handed out in a game format where we're actually, this is an NIH funded research project we're working on at the moment, where you can have groups of students working together, and it's more of a game. It's a collaborative game. So and the way it works is that the students are given questions, and then they're given some number of questions. Maybe it's 4 or 5 or 10 or 20, and they're competing against every other group of students in the class.
Does that end up in the tournament?
It's sort of like a tournament, yes.
Okay.
Yeah, good question. Someone is very observant.
Well, I'm sitting close to the board, so.
Okay. Good question. Not released yet, but it may actually be released soon. If any of your folks are interested in playing with it, more than happy to have folks play with it. If anyone wants to be a guinea pig for that functionality, it's actually pretty cool. So back to this assignment. We created this assignment. We're going to make it an individual assignment, and we're going to hand it out with delayed feedback, which means that the student doesn't know if they got the answer right or wrong until after they hand it in, and then they get it back from the teacher. Immediate means it's just kind of like we saw before with that math whiteboard assignment, where as soon as you enter an answer, you know if you got it right or wrong. So immediate feedback is really great for practice, where delayed feedback is maybe good for kind of assessments. So I'm going to click on assign document. So this will take this assignment with this activity, it's an exit slip, if you will, and hand it out to all the students in my Algebra 1 Period 1 class. So on the left-hand side, I have a student account. So that was the teacher on the right-hand side. On the left-hand side, this is a student account. And you'll see this is the student looking at the assignments in the Algebra 1 Period 1 class. You can see up here, Linda 1 has never been visited. These are all the other assignments that have been handed out across the school year. Up here, we'll click on Linda 1 and we'll open up the assignment as the student and we'll see what the assignment is. Okay, the assignment, we can see the assignment looks just like what you see on the right. That was the teacher on the right-hand side. But on the left-hand side, again, this is the student. Student cannot see the answers. So maybe the student works through this. We already worked through this. So, what's really great about Fluid Math and Math Whiteboard, which is different than a lot of other online tools, is that the students get to show their work. With a lot of online assessment tools, the student just enters an answer. And maybe if they have to work through the problem, they work through the problem on a piece of paper on the side, and then they throw the paper away. So you, the teacher, never get to see what the student did to show their work, and the work that the student did. You only get to see, if you get to see the answer they entered, which sometimes you don't get to see. Maybe you only get to see the overall score, but maybe you get to see their answer, and that's usually the best you can do. But within the Fluid Math and the Math Whiteboard system, the idea is that it's like we're modeling paper and pencil. So, the student can show their work up 2/1, so they can write in an answer 2/1, and then they can show more work on the page. Again, if they need to write more math on the page, they can write more math. So I'm going to get this answer wrong again, just so you can see how the system handles wrong answers. So again, the student can write more math. These are pretty simple questions with not a lot of work to show. But if you have these, longer problems with more involved answers and solutions, you'd want to see how they show their work. So the student up here clicks the submit button. Let's go see on the right-hand side what the teacher gets. So that was the student on the left-hand side. On the right-hand side, we're going to see what the student gets. I'm sorry, what the teacher gets submitted by the student. So the teacher goes into the Algebra 1 Period 1 class, individual assignments. And you can see here that here's the assignment, Linda 1. It has, these are the students, my 4 students. You'd probably have 20, 30, 40 students. And you can see that the student got a 50%. So the system automatically graded the work. These students haven't submitted anything yet, but let's go take a look at what the student submitted. So we can see it took, the student got a 50%. It took 95 seconds to do the work. It was submitted 34 seconds ago. Let's click on the assignment. And again, this is the teacher on the right-hand side reviewing the work by the student. By the way, I'm going to expand the page here because in addition to reviewing the work, I want to give a little feedback to the student. So we'll turn on our red markup pen under the draw key. I'll turn on my red markup pen and we'll mark this up. So, oh, by the way, you'll see here, again, there's a check mark and an X. The check mark at the top of the check mark says equivalent because the expected answer was 2. The student response submitted was 2/1. If I don't like the answer, it says click to toggle. Like if the answer is in the wrong form, I can click that check mark and turn it into an X. But I think actually the answer is pretty good. It's in rise over run form. So I'm going to give some feedback. I'm going to say good answer. All right. And then down here, I'll give some more feedback. We'll say X comma Y versus Y comma X. And then in our system, if you like, you can have the students resubmit their work. So you can say try again. And then we'll put a smiley face on the page for the student. And we'll click the send feedback to student button. So that was the teacher on the right-hand side giving meaningful feedback and sending the feedback to the student. On the left-hand side, let's go see what the student gets. So the student now can review that assignment and the feedback from the teacher. So let's open the assignment here as the student. So this is the student reviewing the teacher feedback. So what we're doing is we're modeling that paper and pencil paradigm. But we're doing it in a digital environment where the student can show their work. the teacher can give meaningful feedback. You can create these assignments or assessments really easily, and they can have those answer boxes, which are self-grading essentially, or auto-grading. And it stays all within this digital environment. Which
Is there a resubmit
what,
button?
what
on
do
the
y'all
top
think
right?
about this? I'm sorry, what's that?
If you expand it in full screen, do you see the resubmit button on the top right?
No, the student would have to reinitialize the document
Oh, okay.
to resubmit. This is just the student reviewing. So when the student resubmits the work, the teacher gets to see both submissions. So the teacher will, and likewise, the student would be able to get to see both submissions.
Okay, anybody have questions? All right, well, I think that wraps it up for us there, Don. Thank you so much.
Okay, yeah, I'd love to get any feedback. What do y'all think? Is this interesting?
Yes.
Well, I think you got a resounding yes, they like it.
Oh, okay, good. Awesome. Well, thank you all so very much. I appreciate your patience. There was a lot to show, as I mentioned earlier. The system does a lot, and I think it's a pretty cool system. So
Okay, well,
I know.
thank
Okay, yeah. If you all have any questions, just let me know. Happy to answer any questions at any time. I know Tamara has my contact information.
he was CC'd in, or you were CC'd in the email, so everybody has it now.
Oh, awesome. Okay,
I
good.
do have a question about EdTech Live. So when you get off, if you could check your email, Tessia Campbell did reply saying that she could meet for a practice connection.
Oh, great. Okay.
And
Cool.
I was hoping you could check your calendar to see if that will work for you as well.
Good deal.
And I never did hear back from Nicole Campbell, the elementary lady.
Oh, okay.
Did you ever
Yeah, I
get a
have
hold
not
of
heard
her?
back.
Okay, then we can just move forward without her.
Okay.
All right.
Okay.
Well,
No
thank you
problem.
for your time.
Thank you
All
very
right,
much.
folks. Yeah, well, thanks again, and look forward to continuing the conversation. Have a great day.
Well, thank you.
Enjoy. Bye now.
He's got no.